I looked at the presentation at frontendmasters.com by Kyle Simpson, and it made me think. It made me think a lot. He suggests to rethink web architecture a little bit and have a new look at the front-end and back-end roles and technologies they work with. More precise, he challenges what defines the front-end domain and what defines the back-end domain. Traditionally, these have been divided by the client and the server side, but as he points out, there are several parts of the backend that heavily affects how the client application performs. Things like session management, cache control, templates, and validation. I could go into details here, but the conclusion is that there is an end to our traditional architecture that kind of falls in the middle, the middle end. To me, this made a lot of sense. My take on this is that our front-end team can focus on building the actual applications, and our back-end team can focus on creating generic RESTful web services used by multiple applications. This puts front-end in a position where they can very easily extend our application portfolio. There are lots of other advantages too, which I'm going to try to explain to you in this video. I should point out that there are many ways to build and use a middle end. This is just a suggestion that might inspire you to build your own. The example boilerplate used in this video might have some loose ends, but the concepts should be easy to explain. If you want to have a look at it, download it from GitHub. So the subject of this talk is this boilerplate I built, inspired by the talk by Kyle Simpson. The boilerplate is a good starting point for any application you would want to build. The boilerplate is actually an application in use by our company, Marcello. It is a simple CRUD messaging application which our operations department use to communicate important tasks. You get a list of messages with some details, you can toggle history, and you can edit and create new messages. So let's dive in. I think it is a good idea to look at the project file structure first. There are a few folders and files here. Not all of them are important to talk about now. You can investigate that on your own. But I will go through some of them. The dev folder is where the client application is developed. You have a CSS folder, image folder, JavaScript folder, a less CSS folder, and a templates folder. You do not really need to do anything in the CSS folder. We use and recommend you to use less CSS. The WebStorm IDE has a very nice autocompiler, and there is really no reason to write normal CSS, as less CSS just adds some really nice functionality. The images folder contains your, well, images. I suggest you take a quick Google search on image optimization. There are some great tools to build sprites and minimize the size of your images. It is pretty amazing how much compression that can be done without losing quality. The JavaScript folder contains a few default files and folders. First of all, you got your app folder, which contains the actual application files. You can see here that we have a few different files, and we will get back to those later. Next, you have a folder with shared modules between the client and the middle end. As you can see, we share handlebar templates, helpers, some date and time handling, and the validation. The vendors folder contains libraries, and the main.js file fires up your application. The config.js file is a small module used by the boilerplate to extract configs from the middle end and makes them available as a config module in your application. The templates folder of course holds your templates. We will look more on them later. The next folder is your deployed project. We use Grunt to optimize and deploy the code. By optimizing, I mean merge all application modules and minifying the JavaScript code into one file using the R optimizer. The CSS is also merged into one file. Your handlebar templates are also compiled into JavaScript functions. All this magic happens when you write grunt deploy in your terminal. Let's do that now, just to see the magic at work. Now we have gone down to about a third of the size, but even more important, we have gone from lots of HTTP requests down to about 3, which we will talk about more later. The node underscore modules folder is all the grunt and middleend dependencies needed. This folder is not to be committed to any repo like Git or Subversion, or any other for that matter. Keep it locally. The next folder is the server folder. It contains a few default files. The authentication.js file sets up the everyauth module for Node.js. Session management is part of the boilerplate, and everyauth seems to me like a very good choice here. The boilerplate is set up with a normal password authentication. The routes.js file contains all of your routes, and the boilerplate adds some new functionality for you to play with regarding caching, AJAX, page requests, and putting data directly into page requests. I will explain more about that later. You also see a fake responses folder here. The folder keeps all the fake responses you want to produce for your application while developing. This is a really nice feature which makes the front-end team a lot more productive. They are no longer dependent on backend to finish or produce the fake data for them. What is really nice about these fake response modules is that you can make them dynamic, send them data based on the session, etc. And there is really nothing to it. They are just modules like any other, but how they are used makes them very powerful in the development process. The last folder is the tests folder. Grunt has a really good plugin using Mocha or any other JavaScript test library to run tests in your terminal. I will not go into this, but there is an example in the boilerplate and some info on it in the README on GitHub. The files in the root of the project are important. First of all, there is the config.json file. This file configures both what configuration variables is to be available in the middleend and in the client. The grunt file configures grunt to deploy your code and run tests. Package.json lists the dependencies of the project and lets you easily install them. The last file is the server.js file. It starts up Node.js Express server, and let's do that now. Both the middleend running on Node.js and the client project uses required.js to modulate the code. This makes it easier to share modules between the client and the middleend. So when we look at the server.js file, we can see required.js being set up. It just sets a base URL and the paths to shared modules. I will not go into lots of details here, but quickly looking through the code, I can mention that we configure Express to get access to the templates located in the dev folder. We also intercept all the requests to check if it has a valid session, and if so, pre-disable all caching and on the response. I do this to encourage giving more thought into what should be cached for how long and what should not be cached. We also add a global variable to our templates, config. Any config set under the client property in the root config.json file will be included in our template rendered by the middleend. The properties defined under client will also be available in the middleend. At the end here, we define a few routes for the example application. So let's head to localhost and log in. We now see that our request to index was intercepted and we were redirected to login. When I now log in, we do a page request to the index method in the routes file. There we go. Let's head into the routes.js file and see what actually happened. The page request arrived at the index method after getting authenticated. First, we check if we are running in development mode. If so, we refer to some fake messages via our messages variable. The fake messages are just a module returning an array of messages. The render method on the response refers to our index handlebars template and gives access to a couple of variables in the template. First of all, we sort and filter what messages to instantly display on rendering the index template using underscore. I use filter to say that I only want messages not part of the history. I also sort the remaining messages by priority first and then by starting time. Then I bootstrap all the messages and information about the user. This bootstrapping function stringifies the objects and makes them handlebar safe. This string will later be parsed into JavaScript objects again. When we are not in development mode, I contact our backend web service for the messages and basically do the same thing. This is a good time to check our templates. Since we are referring to the index template, let's head over there. As we can see, the index template is an extension of the default template, so maybe we should start there instead. The default template sets up our basic HTML and defines where our index template should be inserted, which is the body handlebar placeholder there. Notice we also have a placeholder for our initial styles, which is inserted by the index template. In the first script tag, we are getting back to our bootstrapping. First, we set a global variable config as our client config from config.json. Then we check if there is some bootstrapping going on, and we set that with a global bootstrap variable. We will look into how these are handled later. The next script tag is actually an inline of the minify required JS library. Why is it inline, you might wonder? Well, we save an HTTP request. There is no reason that we need to do a new HTTP request to get this code. You might say that this will cause a delay in delivering the HTML to the client, and yes, it does. But not including it and setting up an HTTP request to get the exact same code takes longer. So, as long as you do not worry that this extra JavaScript code causes a delay that tips initial download time over 100 milliseconds, it should be included. So why 100 milliseconds? Well, because that is where your users still feel like it is an instant render. Above 100 milliseconds, they will start to notice a delay. So, is this really important? Yeah, it is. The first experience your users have is loading your application. If you can get it to feel instant, you get bonus points. The last script tag checks if we are in development mode. If so, we asynchronously load any CSS files in the CSS folder. In production, we only have one CSS file. When we now go back to the index file, we first see that we are loading some inline CSS styles. The inline CSS loaded here is critical for displaying the initial page. It should only contain what is absolutely needed to render the page requested. As you can see, I am loading the whole Twitter Bootstrap CSS, which I definitely do not need, but I am a bit crazy and did it anyway. Actually, to be honest, the customizer over at Twitter Bootstrap does not work very well. I only wanted some model stuff and a table and some layouts, but when I chose those, there were still a lot of CSS missing. I do not have time to figure out the dependencies, so I inserted the whole thing. The rest of the CSS is mine, and it does some changes to the default Bootstrap CSS and some other nice stuff. The rest of the index file produces the rendering of the actual page. As you can see, there is just some navigation, a search input, and the table with the messages I filtered and grouped in the index method in routes. And they get inserted with the partial template message here. What is especially cool is that the middleend partial template of the message is the exact same that the client uses. At the very end, I insert the model code for Twitter Bootstrap's awesome model. So let's take a look in the browser. It takes between 100 and 150 milliseconds to render the page. After the rendering, about 26 XHR requests are run to load modules and templates, which ends in about 250 to 300 milliseconds total loading time of the application. Notice here that the initial rendering does not give any functionality. It is just static HTML. When required.js loads up the main JS file and the rest of the modules, the application actually works. To me, it was important to make the user feel that this was an instant load, and the 150 to 200 milliseconds between rendering the page and actual page application load time is so low that they would never notice that the application was not actually loaded. But they would notice if it took 300 milliseconds or more to do the rendering. So what happens when we deploy this code? The size of the development folder is about 900 kilobytes and the distribution folder is about 300 kilobytes. I change the public folder to the distributed one and deploy the code. Note that this quick fix will load a non-existing CSS file, but it does not affect our test. Let's have a new look. There are only 3 requests, and the whole application loaded in about 200 milliseconds. That is a huge difference on such a small project. If you noticed, the page rendered after about 100 milliseconds both on the development and production version. That is because the first request is the same, but the time it took from the page rendering until you could start using the application took 200 milliseconds in development, but under 100 milliseconds in production. That is where the difference is. It does not matter if you want to go for instant render or a progress bar. The bigger your application becomes and the slower your environment gets, these are the kind of optimizations that will give a good user experience from the millisecond the user hits enter in the address bar. But what about the messages displayed here? There were no XHR requests for them. Where did they come from? If you remember us bootstrapping in the index root method to the default template, we can take a look at how this data is handled. To make this generic and easy to use, I overrided a couple of backbone methods, the model and the collection fetch method. Backbone uses a fetch method both on the collection and the individual models to get data from the server. Since we already have the data, we can do an extra check before we contact the server. If it's there, we use the bootstrap data instead. If we take a look at the main.js file, which boots up the application, we can see the 2 override methods. What basically happens here is that it checks if the collection or model doing the fetching has a property called prefetch key. If it has, it looks that key up in the global bootstrap object and silently adds that data if available. It also deleted the bootstrap data, so that the next time the collection or model does a fetch, it does it from the server. If we take a look at my messages collection.js file, we can see that the prefetch key is messages, which is exactly what we bootstrap in the index root method. The subject of this video is not Backbone, but one thing I should bring up is the validation. Backbone does have a very nice validation plugin, but it got a bit too much for me. So I built a small validation tool for this application, which I have an article on if you want to know more. Taking a look at the message model file, we can see that the validate method is set by calling validate.backbonemodel, and we pass a string of message. The message string here refers to a validation I have set up in a module named validation. Let's have a look. Okay. So the validation module depends on my small plugin called validate. This plugin lets me do a few different things, but what I am doing here is using the extend method to set up a general validator that could be used throughout the application and also in the middle end. I call it message and set what properties to validate with what. I run the model's validate method by calling the isValid method on the model somewhere else in the code. That is not important, but what is important is that the exact same module validation is used in the middle end when I request the creation of a new message. As you can see on the create message method in the router, I validate a message using the request body, which contains the attributes of a message. When the validation is run, I can check its validity by testing the isValid property. I have not talked about caching and contact the backend RESTful web services, but I guess that will end up here in not too long also. Thanks for listening.